Okay, students, it's going to be a quick video on stoichiometry with gases. So it's still our basic stoichiometry. Still, how much stuff did we use in a reaction? How much stuff did we make? Okay. It'll be important to know which things are gases, which things are not. I'll tell you in this reaction we're going to use right now, everything is a gas. So if you start in grams, like we normally do, we turn into moles. We do our mole ratio to get from one thing to another. If we start in liters, we'll do the same thing. Turn in moles, do our mole ratio to get from one thing to another. So the only difference here is going to be with gases is we could start with liters or we could finish with liters. Whereas before it was always grams or moles we started with and grams or moles we finished with. So if we think about things, this ratio out here is a 3:1:2 ratio in terms of moles. If those things are gases, that could also be the ratio in terms of liters or in terms of pressure, because remember at STP, at standard temperature and pressure, 1 mole of any gas takes up 22.4 liters. So it doesn't matter what gas it is, a mole of it takes up that. So if you have 11 liters of a gas, it's going to be half a mole, no matter what the gas is. Okay, that stays that's pretty true in real life. So this ratio up here we'll typically use as moles, but it could be a liter to liter ratio if we're doing two gases. So this one you're saying you got 35 grams N2, so the same thing, 35 grams N2. So we're going to take our grams N2, turn into moles, just like we always do. So N2 would be 28, not 14, because it is N2. So divide those two to get to moles N2. Trying to get from nitrogen to ammonia. Well, it's a 1:2 ratio. From nitrogen to NH3. So for every 1 mole of nitrogen, there's 2 moles of ammonia. So get our grams into moles. Our ratio gets us to moles of ammonia. Wants to know how many liters of ammonia we can make. Well, since we're at STP, a mole is 22.4 liters. Remember, that's only true for gases, only true at standard temperature and pressure, 0 degrees Celsius, 1 atmosphere pressure. So we can say a mole of NH3 or a mole of any gas takes up 22.4 liters of space at STP. Multiply across top, right by the bottom, get our answer. It's about 56 liters of NH3. Second problem here. This one is saying you have 14.5 liters of nitrogen, again, at STP, at standard temperature and pressure. If we're not, we're going to have to use a different thing, PVNRT, ideal gas law, to get things. So you have 14.5 liters of nitrogen, and we're trying to get to how many liters of hydrogen. So we're here, going to here. So I'll show this 2 different ways, but we'll say we have 14.5 liters of nitrogen. We're going to turn that into moles. So liters to moles. So now we're not using the periodic table. We're going to say that a mole of any gas, mole of nitrogen in this case, at STP is 22.4 liters of space. Now that box I've got is how big it is. So 14.5 liters then to be a little bit less than a mole, because 22.4 liters is a mole. That gets us to moles nitrogen. Our ratio is 1:3. For every 1 mole of nitrogen, there's 3 moles of H2. Remember, that's a mole-to-mole ratio. I didn't write the word mole in there, but it's a mole-to-mole ratio. So those cancel. And then we can go from moles to liters. Well, a mole of hydrogen at STP is 22.4 liters. If you notice on this, we dividing by 22.4 and we're multiplying by 22.4. Well, it's the same as those canceling out. So we're going to really just multiply 14.5 times 3, which is 43.5 liters. Well, let's go back and figure this out again. As long as these are at the same ratio and they're all gases, we can use this as a liter ratio. So I could have just done 14.5 liters of nitrogen and just said for every 1 liter of nitrogen, there's 3 liters of hydrogen. So this could be a liter to liter ratio as long as they're at the same temperature and pressure. If they're not, then we can't do that. Then the moles will be different. One more question. We got 4 moles of ammonia are being made. So we got 4 moles of this being made. How many liters of each reactor are used? So we want liters of this, liters of that. And we got 4 moles NH3. For every 2 moles of NH3, there's 1 mole of N2. So that gets us to moles. Divide this by 2. And then at STP, we know that a mole of N2 is 22.4 liters. Remember, you can only use this at STP. We're going to do some later. They're not. So that'd be 44.8 liters of N2. If we're going to H2, the only thing to be different would be our ratio. So I'm just going to change the ratio here. If we have 4 moles of this, it's a 2 to 3 ratio. So instead of having a 1 up here, I'd have a 3. It'd be H2. That's all it's going to change things. And that'd be, it's 134 liters. Of H2.